Yeah, you pretty much arranged it like we did. You remember the Brain OS robot? That's all you do. Alexa, stop.
I'm flying.
You're fine. Goodbye.
Hey James,
Right. Yeah, mate.
how's it going?
Yeah, not too bad. How about you?
Good. Are you in your backyard?
I am. Kids are asleep, so I'd find somewhere quiet.
Nice. Okay. Did you say kids?
What my niece says.
Your nieces?
Yeah, it's not actually my kids.
Okay, I almost thought you had kids for a second.
No.
Hold on. Let me text. I'm texting Rick and Jill if they're gonna join. Sometimes they are forgetful. How's it going though? Otherwise,
Yeah, it's not going bad. I mean, work's been a very stressful week because the two senior dads on the team have gone on vacation.
oh no.
Conveniently timed when we're trying to get a release out, which means I have to do the release.
I see. So how big is your team there?
So it's a pretty small team, to be fair. We have the Android team and the iOS team in one squad. We're the only team at the company who do that. So with everybody in, it's about 12 people. But iOS at 4 people.
Yeah. Okay. So, how long have you been with that team?
It's pretty much since I started my placements, so nearly 2 years now.
2 years. It's really interesting. Like I guess the career trajectory you've chosen or that you're trying to do. So you started developing at 16, right? And
Well, I've been doing it for like years, just on my own. But
for years on your own. But so
yeah,
am I right to assume that you've just been developing, like I guess professionally since 16 and didn't go to like a higher education or anything?
No, so I did an apprenticeship, which I skip university, get the qualification that way.
Nice. Apprenticeship. So is that like trades? What we would call trade school here in America?
Basically, you learn in the workplace essentially.
Okay. Cool.
Awesome.
Yeah.
Can you hear me?
Yeah. Hey, Rick.
Okay.
Now we can hear you.
That's the future of education.
That's what I was gonna say.
Yeah. This is how it's all going to be. The whole university system is going to just like it's going to go down like the Titanic.
That's what I was gonna say. I was gonna say kudos to you, James, for like recognizing that, whether I don't know, maybe inadvertently, but I don't know, or maybe intentionally. But yeah, I think like now in the age of software, I mean, you get paid so much as a software engineer. Like if you want to be a software engineer, like yeah, why waste 4 years of like some of the most malleable time, or in terms of like learning, like at school, when you could be, yeah, I mean, learning like on the job.
Yeah, I'm just not a very academic person, so I never learn in that sort of environment of just sit down and work.
Yeah.
Yeah.
I learn a lot more through.
I mean, the point of going to a university for computer science is to get a job as a software engineer anyway. I mean, that's it's a means to an end. But if you've already got to that end, then yeah, you've saved yourself a bunch of time. So yeah, I mean, I think that's smart, and I think that's what the future will like get to. So you're a little bit ahead of the curve.
I wanted to check on what was going on real quick, but I know I go back to. I'm working with Daniel right now. He's setting up his plant bot. I'm helping him.
Okay.
I'm gonna get back to that.
Okay. Well, all right. Well, nice of you to check in, Rick. We'll see you.
All right. Yes.
All right. See you.
Cool.
All right. Well, Jill, I guess she might be busy. She mentioned so before that she might be busy this weekend. But anyway, let's just do the stand up together. So here, I'll go first. Let's see. So whatever. So okay. So we have a few major issues, namely like our performance. So we've just given these telebot prototypes. You've seen our new telebots. We've built, I think, 5 of them, and we're giving them out to a bunch of influential Twitch streamers, and a lot of them have a bunch of followers. K-Pike Fashion has a bunch. She was supposed to come online yesterday, but I guess she had some technical issues. But the point is, like we already maxed out our CPU on our AWS instance already, and that's that's before this expected surge in traffic. So what I've been working on is CPU profiling through JetBrains' WebStorm tool, and I couldn't really make too much sense of that. Let's see what else. CPU profiling and oh yeah, clustering. So in Node, there's this thing called clustering. So Node by default, Node.js by default just uses one core. So like everybody has to find out their own clustering solution. So I've been trying to use this library called PM2, which is one of the most popular, and it's supposed to handle, of it, yeah. And it's supposed to handle clustering and everything. The only problem is it doesn't work well with Socket.io because the session data apparently gets stored in one core, or like one instance, I guess, or whatever. So it doesn't share the state of the sessions, and then like our robot clients can't connect because it says like you get an error that says like session ID not found or something. So I've been trying to figure that out, but that's also pretty hairy. I've been just like looking through like very undeveloped third-party libraries that have tried to solve this, but couldn't get those to work. I mean, there's nothing really too robust out there or too recent out there. So that's a big problem. And I mean, we can upgrade our AWS instance. It's just right now, if we're on one core,
Not taking advantage of what?
yeah, we're not taking advantage of the upgrade. So there's really no. I mean, you do get a marginal CPU performance upgrade, I suppose, especially if you move to like the C type instances, because those are compute optimized. But I mean, it's probably marginal. I think Jill's gonna join, by the way. She just texted me.
Okay. Would it be simpler to have more smaller servers than having one big one?
Smaller. What do you mean? Smaller servers?
Yeah, so instead of having like everybody on one server, having like one like a host server, but then having multiple that sort of read off it, a bit like a CDN network.
So do you mean like a load balanced solution, hey Jill?
Essentially, yes. Just put everything on the main one.
Yeah. So yeah, that's another thing we've thought about. Like basically copying instances of the main app and like somehow load balancing perhaps through a web server or like Nginx or reverse proxying, I don't know, but load balancing that way rather than using nodes clustering thing, but rather just spinning up a bunch of instances of the app and like doing whatever external load balance. I mean, we've thought about that. It's just our app's not right now in a state to do that because it's not stateless. It doesn't have everything stored in the database. It has some stuff stored in memory, for example, the users list and things like that. So we can't do that right now, although we should start making inroads to that. I mean, that's going to have to happen at some time anyway. But yeah, I mean, so yeah. So anyway, so going back, yeah, CPU right now is something I'm, taking a look at. It's a big problem to solve CPU optimization. I mean, there are also some other ways we could help this. We can like reduce the amount of commands that go through. That's also tricky as well. But anyway, like right now, when you press buttons and stuff, it sends a command to the robot. So we can try to find a way to reduce that for every user, and hopefully that would that would relieve some of the CPU usage, but it's not guaranteed either because each message, I don't know, it's tricky. Like, because if you start to throttle on the app side, each message is going to go to the server anyway, but then be throttled, and maybe that's what will cause computation. Maybe that's where the computation cost is coming from. So it's tricky that way. And there's another thing we can do, or wait, let's see. Let me look at my notes for a quick second. Sorry, let's see. Okay, so yeah, we can reduce the message rate. Oh yeah, there's also allegedly a CPU leak. We're not 100%, and we don't know where in the code. It's like we don't even know remotely where in the code where it might be, but at least what we've seen is the CPU does hit 100% and like stays at 100%, or like more or less stays at 100% sometimes. And like we haven't had too much information about like, is that built over time? Does it happen consistently, like over time, or does it just get to this weird state, perhaps, and then start to max out the CPU? We don't know too much, but anyway, we call it the CPU leak. So we need to find that as well. That's what I was trying to do with the CPU profiling. So we can help the CPU usage that way, finding the CPU leak, minimizing that, also minimizing just computation in the app itself, for example, throttling the message rate, and then of course the clustering, and even later down the road, some kind of load balancing between multiple instances of the app, and also we could increase the AWS instance. But anyway.
You don't think decreasing the message rate will mess with the robots?
I mean, it depends how much you decrease it, but we can decrease it a little bit, and have it not mess with the robots. Because like there's that period of time when the robot is moving and not receiving or not doing another command, right? So it's like,
Yeah, but that varies from robot to robot, right? Like what? I don't know. Like comparatively, like messages compared to like video, right? Like what's the percentage of CPU?
well, so we would, I mean, I would think it's actually in the messages because the video is handled by our relays, which is sort of like a microservice. And when you do a top command on the server, which shows you the CPU usage, you see one node instance, which is probably our main app. I mean, almost for sure is our main app. And that's what's hitting 100% CPU. So if it was the video, you would see there's a whole bunch of like other node processes, and those are our relays. You would see those, you know, like hitting 100% CPU, but we don't. We see the main app hitting 100% CPU, and that's not handling the video. So
Okay.
that's what would lead me to believe it's something, you know, yeah, it's probably related to commands because right now that is our most computationally intensive thing because we do that whole, you know, voting system thing, the mass user interface. So yes, I mean, so right now we send messages at a very, you know, high rate. So I think we have some room to decrease that without affecting robots because there's no way the robots need all of those messages.
But I feel like that's still decreasing the messages won't solve the underlying problem of Maximus.
Yeah, well,
No.
the underlying problem, if that CPU leak is real, that's the underlying problem, which, you know, is important to be solved. But anyway, I'm still trying to investigate where that's coming from.
Do you think that's related to like the React memory leak thing you had talked about earlier?
No, because React is client side. This is
Okay.
a server memory leak.
Okay.
Yeah.
Got it.
So yeah, React would be just your web browser they have open. If your web browser starts to lag, then that's probably the React memory leak, which I've more or less taken care of, so that shouldn't be an issue. Anyway, all right. So just to finish my stand-up off, so I'm working on that CPU leak or the CPU performance issues, and the next big thing on my list is the RoboCaster page, and with that, I mean, really what that means is the new visual design. So we've been on this design for a long time, and it was just, you know, impromptu put together. So we're moving to a design that Joe put together for the RoboCaster page, and hopefully there it will also help the Twitch streamers. It'll show, like, I don't know, they could put on their link to their Twitch pages, their Twitter pages, whatever, so it'll feel more, yeah, I mean, it'll be better for those Twitch streamers, so they don't feel like they're sort of nameless on our site. They're sort of promoted. All right, well, so let's see that, and then of course I've been helping Sherlock or James with a few things. What was that?
Oh, I accidentally kicked myself out. I was just gonna.
Oh, she kicked herself out again.
I didn't come with a logo, so
Drag and dropping images does not work.
Oh, okay. You're trying to drag and drop images. Well, I think
Yeah.
James. What were you trying to show?
Oh, I was just gonna send a screenshot of the thing that I was doing more recently.
Oh, okay. Yeah, that'd be cool to see. I'd be interested in seeing that. So yeah. By the way, Rick had joined, but he left because he's on a call with, or not on a call, but he's helping Daniel Tompkins right now set up his robot.
Which one's Daniel
Daniel
Tompkins?
Tompkins is the Florida dude that has the business application.
Okay, yeah. Javier needs some help too, like his Wi-Fi.
I saw that this morning, and I said a few things I suggested a few things to him. Yeah, I don't know. Let me see. Yeah. Anyway, I told him to check his Wi-Fi name and password on the profile site, and also his WPA supplicant file. Oh, he said he fixed it. He said.
Oh, cool.
He said he put in the number of the default network profile. I don't know what that means, but anyway, he fixed it. All All right, so my stand-up's going pretty long, but anyway. So the Robocaster page, the clustering stuff, helping James with a few things, like API things for the mobile app. And then there's another thing that we can try, which is to detach the relays, those microservices, the video microservices from the main app. And the benefit of this is then we can restart the main app without having the videos go down. So without having the black screen, we can restart the app and release that memory or that CPU leak without having the videos have to go down.
Okay.
Yeah, anyway, those are my big things that I'm working
The
on.
audio relay would be nice to have separately, I think. I feel like that's a good like stopgap right now. Like if we separated those processes out, so that way like the audio and video can stay.
Yeah, well, I tried. So the audio thing. Yeah, I mean it is separate already. The audio relay, it's separate. It runs as its own node process. And I tried yesterday when Little Geeky was having audio issues. I tried restarting just that one microservice, and it didn't work like I thought it would. I thought it would just kill that and then bring it back up, but it killed it sort of permanently. So I had to restart the app. But yeah, I mean, yeah, it would be nice if we can just kill those separately from the main app and have them come back. But of course, that doesn't solve the underlying issue. Is why does that even happen? Anyway, that's yeah. So those are the things I'm working on. Let's move on to James. How are you doing? What are you working on? Oh, he just went inside. I think he's moving. I mean, like, moving his position.
So I guess while we're waiting for that, so Puncher Space and Bonsai, both their robots worked right away.
Nice.
I had a lot of connectivity issues. I'm not sure what was up with that because that was the robot that had like the best internet connectivity, like it could do it the fastest, and like a few other things. Like I took extra special care with that robot and tested it a lot. So I was really surprised that it had issues. I feel like the issue was more like their internal network, and maybe they had some security feature on their router that was blocking the signal. Because they were able to log into the robot, like it was really slow for them to log into the robot, but they could log into it and set the Wi-Fi, but then it wouldn't actually go online. So it should have worked, honestly, and it didn't. And then like I was kind of also. Are we recording, by the way?
Yes, or we're streaming. Yeah.
Yeah. Can we stop?
Okay, hold on. All right, see you guys.